pine trees were planted in the 1990 celebration of Earth Day. The trees have grown at an average rate of 9 inches per year. In 1994, the trees were 5 feet tall. Write an equation to represent the height of the trees in terms of years since they were planted, and find the height of the trees when they were planted. So, what we want to do first is gather information from this problem. Okay, so we're going to treat 1999 as like year 0. Okay, so this is when x equals 0. Okay, but they don't tell us how high it is, but they tell us the average rate. So anytime they give you like the rate, which is the per year, per month, per whatever, anytime they give you the rate, that is always going to be your slope. So the slope is 9 inches. Okay. So in 1994, so that's 4 years later, so we're going to make x4, the trees were 5 feet tall. Okay. So if I look here, the rate is in inches, but the height is in feet. So I need to make them both the same. Okay. Now it doesn't really matter whether you change to inches or feet because they don't specify. So if you're going to change the feet to inches, you would do 5 times 12. Okay. Or if you're going to change the inches to feet, which I'm going to do because it's just going to keep the number smaller, you divide by 12. This is 9 out of 12 inches. So that makes my rate 3/4. So make sure your rate matches the height. So I've gotten my slope. Then here I have an x value, but they don't give me the y value. Okay. But in 1994, I'm using that x value as 4 because it's 4 years later. The trees were 5 feet high. So now I have the slope and a point. So I'm going to go to point slope form. So y minus 5 equals 3/4 x minus 4. And then they don't specify what form, but typically with word problems, I do think it's easiest if you put it in slope-intercept form. So I'm going to go ahead and put this in slope-intercept form. So I'm going to distribute that 3/4 first. So that'll be 3/4 x. This will just end up being minus 3. Remember, you multiply numerators, multiply denominators. And then I'm going to add the 5. So that'll give me y equals 3/4 x plus 2. Okay. So that's our linear equation. Okay. And then we also want to find the height when they were planted. So when they were planted, that's when time is 0. So that's when x equals 0. So you would just plug a 0 in right there. That's just going to 0 out. So you would have y equals 3/4 times 0 plus 2, making that height 0 plus 2. So that means the trees were 2 feet when they were planted. Now let's go ahead and look at one more example. A small business purchases equipment for $875. After 25 years, the equipment will have no value. So they did not give us the slope on this one. For them to give us the slope, they would have to say the equipment depreciates this much per year, okay, which it doesn't. So we are going to have to find the slope. That means we have to get 2 ordered pairs out of the problem. Okay. So when a company purchases equipment, that's times 0. Okay, that's the very start. So at the very beginning, you always make times 0. And then the dollar amount is going to be $875. And then after 25 years, the equipment will have no value. Okay, so I'm making my ordered pair time for x. Your time is typically x. Your money is typically y. Okay. So to write a linear equation, I'm going to have to find the slope. So 0 minus 875. So subtract your y's on top. Subtract your x's on the bottom. That'll give us negative 875 over 25, which is going to end up being negative 35 for our slope. Okay, so I know my slope, So from there, I can go to point-slope form and then go to slope-intercept form. But if I look here, this is the y-intercept. Remember, the y-intercept is anywhere x is 0. So on this one, I can go straight to slope-intercept form if I want to. Okay, if you're not sure, I would always start in point-slope form and then distribute and move your other term over. So there's our linear equation. To find the value after 2 years, okay, so remember time is my x value. I'm just going to plug in 2 for x. So that'll be negative 35 times 2 plus 875. So that's negative 70 plus 875, which is going to make our value $805. Then for this last part, part C, when is it worth 175? So money is our y value, so I'm just going to go to this equation, plug in 175 for y, and solve for x. So the first thing I want to do is subtract 875. So that'll give me negative 700 equals negative 35x. Divide by negative 35. And you're going to get x equals 20, and it's in time, and our time is years. So we're going to put 20 years.